Let's just sum up solubility product and see what are the kinds of the questions you can get in solubility product. The first kind of a question you will get will be to calculate mass of a salt in an aqueous solution using solubility product. Then the same question, instead of aqueous solution, you can be asked to calculate in a common ion solution. And the third kind of a question you can get will be, again, the reverse of what you learned in 1 and 2. We calculate KSP from mass of the salt in aqueous solution and KSP from mass of a salt in common ion solution. And the fifth kind of the question you will get will be KSP and complex formation. And then even the same thing with the complex formation, you can be asked to calculate the concentration of ions. This will be a large K question. Now let's take an example of each one of them and see how to work on it. Calculate the mass of calcium sulfate that can dissolve in 400 milliliter of aqueous solution. The solubility product is given. So we will do it in 3 steps. The first step, we will calculate the solubility of calcium sulfate in moles per liter, then convert it into grams per liter, then we convert it into grams. So the first step, to calculate in moles per liter, write down the ionization equation of calcium sulfate giving calcium ions and sulfate ion. The initial concentration is 0,0 and the S, it will change as S. So for the final equilibrium concentration is S. So substitute all the values into the KSP equation and the value of S you can calculate, and that comes in moles per liter. Now this value I have to convert it into grams per liter. In order to do that, just multiply it by the molar mass and I'll get the value of S in grams per liter. Then after getting the value of S in grams per liter, I need to get the grams of calcium sulfate. So that's a step 3. So multiply it by the volume. I will get the mass of calcium sulfate in grams. Calculate the mass of PbI2. Solubility product is given, that will dissolve in 3 liters of 0.20 molar potassium iodide solution. Molar mass of PbI2 is also given. So the difference between this question and the previous question is, in this case we are dissolving the salt in a common ion solution, potassium iodide. Therefore, concentration contribution from potassium iodide will also be there. Potassium iodide will ionize as potassium ion and iodide ion, and therefore the concentration of iodide from potassium iodide will be 0.20. So when you construct the ice table, put the concentration of iodide as 0.20 and not 0, and calculate the change and the equilibrium concentration. Substitute all the values and get the solubility in moles per liter. After you get the solubility in moles per liter, convert it into grams per liter. And as you know, once you get it into grams per liter, I can calculate the grams by multiplying it by the volume. So multiply it by the volume and get the mass of PbI2. A mass of 0.12 gram of copper bromide dissolves in 4 liters of aqueous solution. To give a saturated solution, calculate the KSP of CuBr. So now you are going to get a question where mass is given and you will be asked to calculate the solubility product. So the first step you will do will be to calculate the solubility of CuBr in moles per liter. So first the mass is given and the volume is given. So that means I know grams per liter is there. So divide it by the molar mass to get the solubility in moles per liter. So once I get it in moles per liter, the question becomes simple. You have to just put the solubility equation and put in all the values and get the value of solubility product. 4.13 times 10 to the power of 11 grams of calcium phosphate dissolves in 400 milliliter of 0.30 molar calcium nitrate. You have to calculate the solubility product of calcium phosphate. So again, the difference between question number 4 and 3 is, here I have an ion common into it. So I am not using water, but I am using a solution of calcium nitrate. So but the steps remain the same. The first step is calculate the solubility in moles per liter using the molar mass. And once you get the solubility in moles per liter, set up the ice table And just remember that to balance the equation, and when you are writing the KSP equation, raise the concentration of calcium ions by 3 and the concentration of phosphate by 2, and then get the value of solubility product. So the only difference in this case and the previous cases, here the concentration of calcium ion is not 0, it starts with 0.30. Let's do the third thing that affects solubility, complex formation. Calculate the molar solubility of silver bromide in a 1.5 molar ammonia solution. The KSP of silver bromide is given 7.7 10 to the power of negative 13. So in this case what happens is, in the presence of ammonia, the silver bromide will dissolve and form the complex AgNH3 twice plus, and therefore the formation constant of the complex is also given. So we need to consider that also while calculating. So let's write down the equation, AgBr solid equation. It ionizes and the KSP is given. Then write down the complex formation equation also. The formation of constant for AgNH3 twice plus is also given. So let's add up the two equations. The Ag plus will get cancelled and I will get AgBr reacting with ammonia giving the complex. And whenever you add two equations, you know that you have to multiply their k's. So when I multiply the two k's, I get the new k as 1.2 10 to the power of negative 6. Concentration of ammonia is given. So set up the ice table and get the concentrations of S. So initial concentration of the complex is 0. So once S is there, what you have to do is just substitute it into the solubility product equation and then get the value of S. And the S comes as 5.2 10 to the power of negative 3. Now let us just compare this with when I don't have any ammonia. When I don't have any ammonia, there is no complex formation and the S comes as 8.8 10 to the power of negative 7. So when I compare the two S's, and you realize that the solubility S is larger when I have ammonia as compared to one when I have no ammonia. So that means that complex ion formation increases solubility. Calculate the cadmium ion concentration, the cadmium cyanide complex concentration and the cyanide concentration at equilibrium when 0.75 grams of cadmium nitrate is dissolved in 450 milliliter of 0.75 molar sodium cyanide. The formation constant of the cadmium cyanide complex is given to you. So the first step we do is to get the concentration of cadmium nitrate. Moles are given. So molar mass can be found out. Using the moles, molar mass and the volume, the concentration of cadmium nitrate is found out. Now then set up the formation of cadmium cyanide equation. So in this case, the concentration of cadmium is what we calculated. And in case of concentration of cyanide, we take the concentration of sodium cyanide and that is 0.75 and the complex concentration is 0. So when you set up the ice table and get the change and the equilibrium concentration, we'll be able to calculate. But before we proceed further, if you look at the value of K, it's a large K reaction, therefore it will go to completion. So because of this, so what we do is we have to get the limiting agent, and the limiting agent in this case is cadmium ion, and since the reaction goes to completion, all of cadmium ion will get used up. Therefore in the change it will be minus 0.007 and the amount of product formed will also be equal to 0.007. So when you have the equilibrium concentration, I will have 0 as the cadmium ion concentration and the concentration of cyanide will be 0.72 and the complex concentration is 0.007. Now in order to calculate the actual cadmium ion concentration, we have to reverse the equation. Let's see how we do it in the next slide. So when you reverse the equation, I get the equation as cadmium cyanide giving you cadmium ions on cyanide and the value of K will be 1 over K. So after that, set up the ice table and take the concentration which you calculated in the previous phase and substitute into it and then with the help of the solubility product, get the, not solubility product, in this case it is a formation constant, get the value of S. And this value of S is the concentration of cadmium ions, and the concentration of cyanide and the complex can also be calculated. If you look at the values there, the concentration of cadmium ion, we assumed it to be 0, but it is a very low value. And the concentration of cyanide and cadmium complex, cadmium cyanide complex, is the same as what we got in the previous page as the equilibrium concentration. Or in other words, if they are asking you the concentrations of all the three, it is only the concentration of limiting agent which will have a very low value. The other two reagents which are not limiting agents, the concentrations will be the same as the equilibrium concentration.